Okay, not sure. There you go.
Okay, brilliant. Thank you. Right, so I will go ahead and try and share my screen. There we go. Can everybody see that?
Yes.
Yes.
Yep.
Good.
Excellent. Okay. So yeah, thank you very much, everybody, for coming along, and thank you, Steve, for inviting me to talk this evening. I know a lot of you know me already, or you've worked with me either during my PhD research or in my previous capacity. But I'll introduce myself again anyway. So yeah, I'm Ellie. I'm currently doing my PhD here at the University of Aberdeen. But I was previously at the Scape Trust, where I was working to research coastal erosion of archaeological sites, working with volunteers all over Scotland. And my current research, my PhD project, is very much a continuation of that work with Scape, because I'm looking at using drones to survey coastal sites and investigate loss to erosion and climate change. And I'm looking at coastal sites really with that sort of particular focus on the islands. And that's really dictated just by the level of threat and the urgency of threat that sites in the islands, particularly Shetland, are experiencing in the face of climate change and of climate-driven coastal processes. Now, I don't need to tell you or any modern audience really about the threat of climate change, because we're all increasingly aware of the threat, I think. And the impacts aren't just limited to the rising temperatures shown by the changing colour of the climate stripes that are alarming poor old Doyle here so much. It's not just rising temperatures, it's changing patterns of precipitation, hotter, drier summers and warmer winters, more frequent and more severe flooding events as well. But there's a lot of uncertainty over exactly how this is going to manifest. And although we can avoid some of the worst effects by reducing our emissions, some impacts are locked in, and sea level rise is one of them. It's a certainty. So coastal areas are going to experience some of the earliest and most visible manifestations of climate change, and particularly accelerated coastal erosion. And the islands, including Shetland, are especially vulnerable to this. And that's really largely due to sea level rise, both in the past and in the future. So just to look particularly at the situation in Shetland and why, even in the context of Scotland, coastal archaeology there is so vulnerable. These graphs, now I know there's a lot of data on here, don't worry too much about it, you don't need to absorb all of it, but the important things are that the different coloured lines for each area are 3 different models of relative sea level rise over the past 15,000 to 20,000 years at these various locations around the Scottish coast. And the important thing really is that it's very, very variable around Scotland. For most of the country, we've had relative sea level fall. Places, if you think of places like Skye or Fife, you get raised beaches. But in the north and west, the highlands and most particularly the islands, there's a history of relative sea level rise. And the reason for that really is glacial readjustment, effectively how the Earth's crust rebounded following the melting of the glacier. So the centre of Scotland, where the glacier was thickest, around about Loch Lomond, the land has lifted up and rebounded as the weight of the ice lifted. But the margins of the ice sheet, so the sort of northern and western peripheries of Scotland, the land is dropping and sea level is rising. And that's what you're seeing here, particularly for Orkney, the Western Isles and Shetland. So you do have this these sort of very variable patterns across the UK and within Scotland, but Shetland actually has the highest relative sea level rise. In Scotland, it's sort of more analogous to the south coast of England. And there's been this history of sea level rise in Shetland throughout the period of human activity there. So all of Shetland's rich coastal archaeological heritage is submerging. So the history of sea level in Shetland is glacial, but the future is very much to do with climate change. We've got rising sea levels due to thermal expansion, just water gets warmer, it physically takes up more space, so that's causing it. And then, of course, you've got the loss of ice sheets contributing more water as well, which is exacerbating that land movement and that readjustment. So even in central Scotland now, sea level rise is outpacing that land rebound. So all of Scotland is experiencing relative sea level rise, but Shetland has the highest projected sea level rise in the future in all of Scotland. So the graphs on the left show the projections for 3 different emission scenarios, from the lowest to the highest, up to 2100. And the corresponding increases in relative sea level in different parts of the country in the maps on the right, the darkest blue being the areas that will increase least, that will experience least increase, and the yellow areas experiencing much larger amounts of sea level rise. And if you look at the maps, you can see that Shetland is projected to experience higher increases than anywhere else in Scotland. Again, you're looking much more like the situation in the south of England. So that is very variable, depending on what happens with those emission scenarios. But whatever happens, sea level rise is a certainty. So whatever mitigation actions we take now, and however we limit future warming, the sea level will definitely rise. And to exacerbate it even further for Shetland, there'll be higher waves in the north, with the loss of the Arctic sea ice increasing fetch. So the waves will have more impact as well, exacerbating that further. So coastal sites in Shetland really are amongst sort of the most at risk from future climate-driven coastal change and sea level rise out of all the sites in Scotland. So in terms of sort of understanding our future erosion risk, we do have the National Coastal Change Assessment, Dynamic Coast, which is a brilliant website. If you haven't been, I really recommend it. They're looking at the future erosion risk, but they are focused only on the soft coasts, which make up 19% of the Scottish coastline. And because it is a national scale assessment, it's quite coarse resolution. So it's not really suitable for looking at like site scale changes and impacts. But what it has shown is that erosion is accelerating and the rate and extent are increasing all around Scotland under all emission scenarios. So the initial phase was a national scale assessment, but the second phase of Dynamic Coast, they are looking in detail at a small handful of sites, one of which is Skara Brae, which is the image you see here. That's the banner image from their website. So that's been selected for its heritage value. And what they're doing there is sort of intensive monitoring, regular repeat surveys, and sort of detailed site scale erosion impact assessment. So there is that need to sort of zoom in and look at sites in more detail to look at their vulnerability. So they're doing Skara Brae, but of course that really is just one. It's an iconic high profile site, but the sort of coastal heritage resource around Scotland really is, it's so much more than that. And of course in Scotland, most of our settlements and activity historically has been at the coast. So there's a really rich heritage of coastal archaeological sites which are increasingly threatened by those climate change impacts. And as I say, that's particularly the case in the islands. At a national scale, we do know a reasonable amount about our coastal archaeological resource already from previous work by Scape. There was a series of coastal surveys, which was gathered over 20 years. The earliest surveys were carried out in the mid-90s, and they were actually done in Shetland. Shetland was one of the first places to have these surveys done. So about 10 years ago, we carried out a desk-based prioritisation of the records gathered by those surveys, and it highlighted the sites that were highest priority for further action, really to sort of start doing something to actively manage and research these sites rather than just watch them fall into the sea. And that highlighted the highest priority sites based on their archaeological significance and their vulnerability. But what it really showed was the need to update those records because they were up to 20 years old, which is a very long time when you're speaking about eroding coastal sites. So at Scape, we took a citizen science approach to updating those records. And I know many people in this audience went out with us and surveyed some of those high priority sites. Because as I say, they were like 20 years old. They were from the 1990s. So we worked with local volunteers to sort of ground truth those desk-based assessments of priority, monitor the sites and provide an update, but also like add local knowledge and local information and start to think about practical actions we could take at some of these sites to rescue information from places that were being eroded. So the results of that were that we had 145 highest priority sites at a national level, which were sort of differentiated based on their vulnerability, but particularly the urgency of the erosion threat, as well as their archaeological significance and the value to local communities. So we had 145 sites nationally, of which 15 were in Shetland. Shetland's actually highlighted as being one of the top 4 priority areas in Scotland, along with, unsurprisingly, the Western Isles, Orkney, and the northern part of the Highlands as well. So if you want to read more about that, or about the Shetland priority sites in particular, the Scotland's Coastal Heritage at Risk project report is available on the Scape website, so you can take a look and actually link through and read about those particular priority sites as well. So those 15 sites were sort of highlighted as being the top priority to really do something at. And it has to be said that the original coastal zone assessment surveys, they only targeted parts of the Shetland coast. They're the areas outlined in blue here. Before anyone asks, I don't know why they targeted those particular areas. I don't know why they were chosen. They're certainly not necessarily the most at-risk stretches of the coastline, but there's definitely scope for a lot more to be out there in areas that those surveys haven't captured. And as I say, they were done in the 90s, so there's a lot of change in that period. So it's been great, really, through the SHARP project that Archaeology Shetland have been involved in going out and updating those records for us. So of those 15 sites in Shetland that were highlighted, some have had some investigation, but others we don't know anything about, but they are all threatened by coastal erosion. At a minimum, they all need regular monitoring, but many do need further work. But the sort of scale of the threat does outpace the resources available to actually do investigations. So we need to prioritise sites further, really look at their vulnerability and the threat. So there's an ongoing need for eyes and ears on the coast, and for sort of robust data for site monitoring and condition assessment, and really understanding of vulnerability at that refined site scale to look at impacts on a site scale to sort of support ongoing management. And that's where my sort of PhD research comes in, sort of in terms of some of the bigger picture and the questions I'm trying to answer. Because the project really aims to sort of bridge that gap between the sort of national scale dynamic coast erosion assessment and the impacts that are experienced at site scale, and the sort of management needs to sort of further investigate some of these sites, resolve those sort of scalar differences between the national scale assessment and the broad brush national picture and the site level observations, and start to quantify some of those records of loss and erosion from our on the ground information. So my project is all about doing a site scale coastal change analysis and vulnerability assessment, really to inform our understanding of patterns and impacts of erosion on sites. And really to increase our understanding of sites and like use them as proxies to understand coastal change, and really sort of fill that need for high resolution monitoring data and regular survey records, using drones to gather that data over short time intervals, that data that both archaeologists and that coastal managers need. So that's the sort of overall grand elevator pitch of my PhD project, and it all sounds very, very worthy, doesn't it? But at heart, I'm a field archaeologist, and it's the sites I'm interested in. And the information they contain. So as well as looking at that sort of broad brush landscape understanding of threat, I'm looking at individual sites as well to investigate them and learn what we can from them before they're further damaged or completely destroyed. So I'm going to try and give you an overview of sort of both aspects of that project, part of my project this evening. So of course, as you've guessed, hopefully from the title, my methods are all about drone surveys, really to get those images of eroding coastal sites. And there's some very clever software which you might have heard of. It's called Structure from Motion, and it turns two-dimensional photos into three-dimensional landscape models. So we have this like bang up-to-date record of the condition of the site and of the landscape. But from that, I'm also mapping the current coast edge gathering historic survey data, old maps, older aerial photos, previous archaeological survey records as well, to get like a time series of the position of past coastlines, and then carrying out a spatial assessment to calculate statistics on the rate and extent of change and the impacts on these archaeological sites. And then at selected sites, I'm complementing that with sort of detailed site level survey and investigation and excavation as well. So I'm applying those really to the priority sites that were highlighted by the SHARP project. These are places that we know are eroding, they're archaeologically significant, and they urgently need attention and monitoring. So the idea is really to apply that methodology to a series of these sites, and I don't know, watch Scotland catch chicken pox. But no, to actually try and turn these sites into a network of observation points for coastal erosion in a range of different coastal environments, looking at the hard coast as well as the soft coast that Dynamic Coast have looked at. So that's the sort of national scale, but in Shetland, there are 4 sites particularly that I'd like to talk about tonight. So on the left, you can see all of the 15 SHARP priority sites, and the sites that I'm going to be talking about are on the right. So as I say, these are places that we already knew were archaeologically significant and vulnerable. And they're also places where you guys suggested that I focus, because that's really important. It's places that matter to the local coastal community. So starting at the site that we probably know most about, Chanarwick in the South Mainland. So it's a southeast facing bay, so it's generally very sheltered from the prevailing conditions until winter 2013 to 14, when it was hit by very fierce storms from the southeast, which caused a lot of erosion. And after those storms, the landowner actually found a human jawbone on the beach. So there was a sort of rapid recovery excavation, which uncovered a male human skeleton who was sort of awkwardly squashed into this grave that was too small, just at the foot of the coast edge at Chanarwick, just behind the beach. So there was also a radiocarbon dating of that jawbone, which came back to between 1760 and 1820. So we think probably what happened was he'd been a sailor who unfortunately had either been shipwrecked or drowned. It was quite common back in the day for bodies that were washed up to be buried as close to the site of finding as possible. So that's probably what we think was the fate of this individual. But at Chanarwick, the discovery of the skeleton drew archaeological attention to a completely unsuspected site that had appeared in the coast edge, because the sea had exposed this sort of massive archaeological structures and features and deposits, sort of given us a slice through a sort of very large structure. So Samantha Dennis, who was the archaeologist taken on to record the human remains, also did a rapid record of the features that were eroding out the coast edge there. So you can see it's just sort of jumble of masonry and those lovely bright colours of the hearth at the centre of the structure. So the following year, after discussions, we at Scape and Archaeology Shetland went back and did a sort of quite small scale investigation of the structures in the coast edge. It was quite small scale, but erosion really had given us this fantastic slice through the middle of the base of the structure. So we had this archaeological section really without having to do much digging. We also had a till step at the base of the section to stand on for access, which was really nice. And we discovered this to be the foundations of an unrecorded broch. So just running through the features that we had in the section. We had an outer wall of about 5 meters wide. The outer face was built of the local Chanarwick granite, which is a bright white, very coarse-grained stone with lots of quartz and mica. So the inner and outer faces of the wall, it's about 5 meters thick, possibly an intramural passageway as well, but we could never actually get properly at that. And if you're wondering why we hadn't cleaned that bit of the section where the broch wall was, it wasn't laziness. it was because we had this little guy nesting there. We'd a fulmar nest with an unfledged chick on the stones of the broch wall. So of course we didn't want to disturb it, but we didn't want to spend the summer covered in fulmar vomit either. So we just left that part of the section alone. So we're never able to fully investigate whether there was a passage there. Now, of course, a circular broch wall would have come all the way around, and we should have had it on the other side as well. And there's no trace of a wall here. I promise it was there, but it'd been robbed out, probably all the way through up to the 18th, 19th century. And you can see the cut, which had removed all those stones and the sort of darker soil filling it, where I think that's Caroline, actually, where Caroline and Steve are working in that photo. And then in the centre of the broch, we had this lovely corbelled structure, which was revealed to be a really nicely constructed well, with sort of small but perfectly formed steps that went down, and it just kept getting deeper and deeper. We stopped at that point because we couldn't physically move around any more down there, but we reckon it went down at least another metre. And it had been deliberately backfilled with layers of beach sand, but also soft clay that contained a lot of charcoal. So we think it might have been the original occupation material was used to deliberately backfill that well. There was then a phase of internal remodelling. So there were inserted piers against the inner faces of the south and the north wall. So that's the south pier there, built against the sort of south arc of the outer broch wall. It had then been subsequently remodelled itself, and the sort of inner face of it was sort of rebuilt with a sort of orthostatic box-like structure on its inner face. That pink layer underneath it is probably the primary occupation deposits, which were sort of reused as a construction material. And then right at the middle of the structure, we had this lovely sequence of hearth deposits as well, that lovely burnt, brightly coloured clay, surrounded by spreads of ash and floor material. But there was also a metal working pit as well, so they seem to have been working metal in the Iron Age period here. So this is the structure as we saw it in 2015 when we first recorded it, and the section drawing that we put together, sort of relating the section itself to the features and the dating. So you can see we sort of got the construction of the broch wall and the well, a phase of occupation, and a period of remodelling when they put in the piers, a further period of occupation, the remodelling of the piers, and then a final occupation period, which continued up until about the 3rd century AD. And there was a wind-blown sand layer that then sealed the structure, and sort of formed the sort of final abandonment horizon. Of course, the erosion had truncated all relationship to the burial, but as I say, we think was just inserted completely coincidentally. The people who dug the grave were probably unaware that the broch was even there potentially. But of course, it was so important because that was the discovery that actually drew archaeological eyes to the area to reveal this sort of previously unsuspected broch. So it was a sort of serendipitous discovery that gave us this opportunity to investigate the base of a broch, the earliest deposits, the construction levels, and the pre-broch layers, and really get the earliest dating evidence right up to the latest survived deposits. So we got this sort of lovely, unique slice through the base of the structure, really thanks to erosion. Now, I am aware that I've been sort of blithely calling this structure a broch, but we had like 1.3 meters of the structure in the section, so only the foundations and base of the building. So how certain can we really be that it's a broch? Because it doesn't really look like Musa, does it? And inevitably, many of the typical broch features have been lost if they were ever there. We don't have the hollow walls, the intramural galleries, the stairways, the wall voids, the scarcement ledges. If they were ever there, they've been lost. But the scale of the surviving wall base and its construction and the sort of visible diameter of the structure, it's all indicative of it being a broch. So although we only have the lowest 1 0.3 meters of the outer wall. It is 5 meters wide, so it's Broch scale, and it does seem to have that inward batter that you get with Broch walls. Now, Noel Foyett, the archaeologist, in his sort of study of Musa, he discusses what he calls the percentage wall base ratio for calculating the height to which a Broch could feasibly have stood, just using its base dimensions. And he applied this calculation to the 27 best preserved Brochs in Shetland. Now, we don't have much left at Chanarwick, but we do have enough to sort of reconstruct its original base dimensions, just based on what we have in the section there. So we've got a 5 meter thick south wall. The north side has been robbed out, but we can assume it was around 5 meters too. And we've got enough of the south side and the internal features to reconstruct an internal diameter of 6.8 meters. So that whole thing gives us an external diameter of 16.8 meters. So applying Noel Foyett's analysis to those dimensions, we can compare the dimensions of Chanarwick to the other sort of best surviving Brochs in Shetland. Now, a higher value of his percentage wall base calculation gives a more stable base for Broch foundations, which essentially means you can build a higher tower. And this gives the structure at Chanarwick a percentage wall base of 59.52%, which is not quite as high as Musa, but it is higher than any of the other 26 Brochs in Shetland that he looks at. So we can say that although the walls don't survive to any height, the dimensions definitely could have supported a tower on the scale of Musa. So Chanarwick was capable of being a Broch tower as exceptional and as special as Musa was in the context of Shetland. So essentially, when you take the dimensions of Musa, it actually superimposes on top of the structures in Chanarwick really, really well. And we can sort of imagine it in the landscape in Chanarwick thanks to drone modelling. So this is a landscape model built from drone images with the sort of idea of how the Broch might have looked had it not been eroded. Because those outer granite boulders were the locally available Chanarwick granite, it was white with quartz and mica, so it would have sparkled in the sun. So it might originally have stood a bit like this at the head of Chanarwick Bay if it hadn't been robbed and eroded. But it was robbed out, and most of the stone probably went to build the township of Chanarwick, which was built through the 18th and 19th century and also now forms an important part of the historic character of the bay, but is now itself abandoned and ruined and falling into the sea. Now, this chapel building here was roofed as recently as the 1972 map. And a lot of the stone that's falling down the cliff is probably actually from the Broch originally as well, which is just in the section just around the corner to the left of this image. So the sort of coastal change assessment I was trying to do had a really good baseline record of the site from our work there in 2015. And when I went back to look at the site last August, it looked like this, and it looks kind of pretty good. You know, it's slumping, it looks stable, it's sort of revegetated, which is great news for the archaeology, really, because it's sort of protecting the archaeological structures in the section, certainly compared to sort of how it was when we left it. But if you just look at that well structure where Simon's digging down there, you can actually start to see it eroding out of the section last year. So the base of the slope has eroded back and breached that well structure, despite that revegetation that gives the impression of sort of stability and stabilisation. So there's a need for sort of ongoing monitoring and quantifying the rate of loss there. So when I went back, I sort of did my ground photography and carried out a GPS survey to record the exact location of photos so that everything I recorded could be accurately located, and flew the drone. That's the front of the well structure there. So the drone just took a series of overlapping vertical and oblique images of the area and of the coast edge and the site in particular. And this very clever bit of software builds a three-dimensional model just from those overlapping images. It reconstructs the three-dimensional geometry of the landscape just from those two-dimensional images. So from that 3D landscape model, built a high-resolution digital elevation model, which you see on the left, and a high-resolution ortho photo on the right. So from those, I was able to digitize the 2022 coastline, as it was when I was there on site in August, and also was able to get the past coastline from a series of historic maps going all the way back to the first edition, 1882. More recent maps, and then coming up using traditional aerial photos, which are much coarser resolution than my drone image, but are still useful for recording the previous coastline. So I was able to get a sort of time series of past coastlines over 140 years from 1882 to 2022. And then carried out this sort of spatial mapping analysis, which casts perpendicular transects across that series of coastlines. And that lets us calculate statistics on the rate and extent of change across a series of different comparisons, sort of from the 140 years up to much shorter, more recent time slices as well. And it also lets us see the sort of areas of greatest loss and erosion. So this is the overall net shoreline movement, the change over the 140 period from 1882. And you can see we've lost up to 14.4 metres in that 140 years. But we're also able to look at much more recent time slices over shorter periods of time. So this is the sort of summary statistics, all the different comparisons. I don't expect you to read them all, but the important thing is that it confirmed a sort of consistent long-term trend of erosion across the whole bay. But it also showed the sort of spatial and temporal complexity of erosion as well. We were able to quantify the impact and the amount of loss over specific periods and specific storm events, which really showed how episodic erosion can be. And comparing those episodes of loss with meteorological records, that sort of allowed those episodes of loss to be related to specific storm events. And that confirmed that it was that series of storms in 2013 to 14 that caused the most damage, because most of the significant loss actually happened over that short period of time. And you can see that the sort of annual change rate over that period was much higher compared to the longer term trend, particularly in the specific location of the Broch and the townships, the area of greatest archaeological sensitivity. So because we've been able to relate the storm records to the episodes of loss and the conditions that caused that erosion, that can then be used to sort of forecast the likely impacts of future storms that have similar conditions, to sort of allow a bit of an early warning for this site and for other similar coastlines as well. And even looking at just the sort of 14-year comparison from 2008, you can see that we lost almost 8 metres of erosion on the part of the bay where the Broch is. So you can see 8 metres of loss on the right, with an annual rate of loss of 0.6 metres a year, which is a dramatic increase on the longer term average. And if you look at just the 8 years from 2008 to 2016, you can see that almost all of that erosion happened in the 8-year period from 2008 to 2016. So it's 7.5 metres of loss on the site of the Broch, and the annual rate of change there is up to nearly a metre a year. So it was that specific period of storms within that time slice that did the damage. It was that specific set of conditions that impacted the coast edge. The other thing it shows, of course, is that they managed to build the Broch, and by extension the township, at the most erodible and vulnerable stretch of the bay that was most impacted by those storms. Of course, if you sort of look at the long-term rates of loss, you can reconstruct where the coastline might have been 2,000 years ago when they were building the Broch, to get an idea of what the landscape was like then. And erosion wouldn't have been an issue for them. So if we look back at the sea level rise models that we were looking at to begin with, those place sea level between 1.2 and 2.9 metres lower 2,000 years ago. So you can see that here plotted on a modern marine digital elevation model. So that locates the coastline between 55 metres and 120 metres offshore of where it is now. So there would have been a lot of land, according to those models, in front of the Broch before they had to worry about erosion. Now, my calculated long-term rate of change going back 2,000 years puts the coastline 100 metres seaward of its current position. So sort of in between, it's sitting very nicely in between these two coastlines, which sort of corroborates my sort of extrapolated rate of change. But you can also extrapolate those into the future to suggest likely impacts of erosion and sea level rise on the Broch at Chanarwick going forward. How much are we looking to lose and over what periods of time? And again, if we take that long-term rate of loss, we could lose, a conservative estimate is 135 metres by 2050 and 3.85 metres by 2100. Although, of course, that is the long-term average that doesn't take account of those sort of episodic intervals of erosion driven by storms. But then when you add in sea level rise, plotted on top of my digital elevation model, it's going to equate to landward movement of between 3 and 5 metres. So if we think about how much the broch might be left, you know, we had a sort of diameter of 16.8 metres. So there could be about half of that of sort of left of intact structure behind the coast edge. But if you look at projecting those rates forward, you could be losing the surviving interior by 2050 and the entire structure by 2100 by the time you look at projecting those erosion rates forward, exacerbated by the levels of sea level rise that Shetland's looking at getting. And then if we think about sort of coming full circle to that, where that grave was, sorry, so that's the sort of scale we're looking at. And if you think about where that grave was, which sort of first drew our archaeological attention there, that mandible gave a radiocarbon date of between 202 and 262 years ago. So the sort of long-term erosion rate means the coastline could have been between 10 and 13 metres seaward of where it is now when that grave was dug. So the grave was, again, quite significantly behind the coast edge compared to where it is now, between 8 and 11 metres probably. The grave was dug but behind the actual coast edge. But so that's the analysis I've done, but of course it's not the end of the story. You know, erosion doesn't stop and coastlines are always changing, they're always dynamic, and the need to keep an eye on them never ever finishes. So hot off the press, there's been a new collapse at Chanarwick just this winter, so just a couple of months after I took my drone survey. So a huge thank you to Steve and to Janet and to Archaeology Shetland for recording and reporting this and telling me about it. You can see that inner face of the south pier has collapsed. It looks like a big chunk of grass and vegetation from above has just fallen off and taken the end of the pier with it, unfortunately. But it actually looks as if the later remodelled inner face of the pier is the bit that's been destroyed. So it's almost as if the process of collapse there has actually deconstructed the site in sort of chronological order, as almost as if it's doing it the way we would archaeologically, removing features in sequence. So it's always worth keeping an eye on sites, even when you think you understand everything about them. It's always worth keeping an eye and monitoring them. And I owe an enormous thanks to Vivian Clark, who went out with his drone on Saturday and repeated my survey. So we've got a fantastic sequence of drone images just from last Saturday, which will be another update to the record, another coastline that we can use to carry out that analysis and really refine our understanding of the patterns of erosion at Chanarwick Bay and the impacts on the archaeological site here. So that's an example, really, of one of the case study sites where I'm looking at sort of bigger picture erosion impacts on archaeological sites. So the next step, of course, is to apply that to other sites all over Scotland and sort of do a similar thing to get that big picture and build a picture of sort of comparative risk of different areas and different types of coastline all over Scotland. Of course, Chanarwick is a bit exceptional, given that we knew a lot about it and had a really good baseline. Not every site is going to have that level of detail. But the work I'm doing will hopefully help to prioritise other sites for future action and help us to make management decisions about sites to prioritise for investigation, because most of these sites aren't yet fully understood. And in many ways, of course, it's worse to lose things before we have a chance to learn anything about them. But at the end of the day, there's really no point just in monitoring sites as they fall into the sea without actively trying to do something about it. And that's where the second part of the project comes in. And because I am a field archaeologist, and because as much fun as it is to fly drones, it's probably just as much fun, if not more, to get in and really investigate sites, get digging and actually learn from them. So I'm going to move on to talk about a few of the sites that we looked at in detail last year, sort of the other side of my project as well. So we're going to move to these are the 4 sites I'm talking about. So we're going to move to the west coast of Shetland to Wolsey's Air, which is a very different site. It's on the north tip of East Burgh. So it's a very sheltered environment. It's very sheltered by the island of West Burgh from the sort of Atlantic influences. Again, it's a high priority site identified by the Scotland's Coastal Heritage at Risk project. It was identified as being a potential Norse period longhouse. So we visited back in 2015, and this is what we saw. And of course, Norse period houses they're really quite rare in a Scottish context and even a Shetland context. So it's archaeologically significant. And as you can see here, it was sort of half on land and half on the beach. So semi-submerged at high tide, but in the sort of very low energy environment. So although the sediments were gone, the wall lines seemed to continue onto the beach, just sort of preserved as stone alignments. But obviously it was under serious threat. It was eroding and it was archaeologically interesting, but it's also a proxy for sea level rise, because if we can date that house, then we know when the coast wasn't there, as it were. So it was described by the original surveyors as being rectangular, but really it's much more sort of rounded, sort of bowed walls, or even oval in shape. So this is a site we'd always been keen to do more at. So we went back in August to do another drone survey, but also to investigate in detail. So there we go. That's the site there. You can see everyone working away there. So as you can see, it is quite a sort of oval structure. And all we did there was cut the coast edge back, just straighten it up to give us a chance to investigate the deposits in sequence, and opened a small test pit in the centre of the structure as well. So the coast edge really had already eroded through the structure, but by just sort of straightening it up, we gave ourselves a chance to really investigate it properly. And when we cut back the coast edge, this is what we saw. So we've got lower layers, we've got wall lines, and we also have what seem to be hearth deposits. So we sort of cleaned and sampled them, and got quite a rich find assemblage out, actually. But we didn't fully excavate. It was really quite a small scale intervention. So we sort of removed everything in sequence, and when we got there, with apologies for the fact that the sun is in this photo, so it makes everything quite difficult to see. The lowest deposit underneath the structure, which is actually now below modern beach level, so it's completely waterlogged, is the sort of original ground surface. It's like a brown clay that has charcoal flecks. So that seems to be the ground surface on which the structure was built. We've got a wall on the south side of that, which was built on that ground surface. And then lying up against that, the inner face of that wall, we've got this lovely sort of burnt, bright orange deposit of clay and peat ash, which seems to be an in situ hearth. Overlying that was another layer of hearth material, with sort of the collapsed curbstones of the hearth structure on top of that. And from that material, Steve found one of the most exciting things I've probably ever seen, actually. Was this lovely piece of Shetland beaker pottery, and it was literally hanging out of the coast edge. The next high tide could very well have taken that away. So we were incredibly lucky to get there just in time to recover the sort of very rare example of beaker from Shetland. On top of that hearth, we had a sort of peat and ash rich sort of occupation layer or floor deposit, which also contains Neolithic early Bronze Age pottery, so a similar period to the beaker material. And then over the top of everything, we had this weird layer of like really angular gravel, which not certain how to account for. We think it might be sort of brought in by a storm, perhaps after the abandonment of the building. But it also produced pottery of late Neolithic, early Bronze Age date. So what we think we have is essentially the outer walls of a structure with a hearth. Although of course it's strange that the hearth doesn't appear to have been central. It was in the sort of shallow scoop with a curbstone that had collapsed. But yeah, because it sort of seems to be against an external wall line, has there been a period of remodeling or reorganization of space, or is it a secondary hearth sort of on the edge of the structure, which we've seen elsewhere on sites of this age in Shetland? Some sites of a similar age have also incorporated burnt material into the walling. So I guess that's a possibility here, but I think we very much got the impression that it was an an in situ hearth with an associated hearth structure. So as ever, more questions than answers, and more work is needed on that site. And I would absolutely love to go back and investigate further, because it's really surprised us. We expected it to be Norse, and actually it's been this really quite exciting late Neolithic, early Bronze Age domestic structure that's producing very rare high status beaker pottery. And the other thing that I noticed, I didn't even notice this on site, it wasn't until I got back and started looking at the drone photos, is that very square sort of alignment. So you can see the oval shape of what we think is the prehistoric house. But there's this very straight, very sort of right angled stone alignment on the beach. And given what you know, there's also later activity there. There's been Hanseatic pottery found there. I was wondering whether this is actually a much later feature, potentially some sort of redesign, intertidal or coast edge feature, sort of formalizing the coast edge here. So yeah, it's still a mystery and more work's needed, but it's a result that we've got a definite date for the building, and it's a serious result that we got that lovely piece of very rare pottery eroding out of the section sort of just in time. I will also be doing the coastal change analysis here, and we also have a 3D landscape model of the entire peninsula, which is I think one of the sort of first landscape surveys of the area, and there's a lot of features in there, more prehistoric structures, later stuff as well. So that's a resource for further research for anyone who wants to investigate the landscape here. So from one house or from one site that was sort of just in time to one that sadly I think we were just a little bit too late for, unfortunately, up in Hillswick up north. So it's a site that was first recorded by antiquarians who recorded a prehistoric midden here. Scape visited with Archaeology Shetland in 2015. Didn't see anything prehistoric, but saw these sort of walls of what looked to be a rectangular structure eroding out of the coast edge. Archaeology Shetland investigated that structure under the turf the following year, and I think decided it was probably a later structure, sort of Hanseatic or post-medieval in date and associated with fishing. There's a lot of fish bone and shell out of there. And then back in 2020, Kevin from Archaeology Shetland highlighted there's a lot of what looked like prehistoric material coming out on this beach. Now, as you can see here, it's a very steeply sloping beach. It's a storm beach. It's a really high energy environment here. So the opposite of Wolsey's there in that sense. It's open to the west. It's very, very exposed. There's a lot of concrete in that photo, as you can see. And that's because the farmer's dumping rubble over the edge just as an ad hoc coastal defence to try and protect the track that runs behind the coast edge there. So all of that's telling us it's a very dynamic, high energy environment. There's a lot of erosion. And I believe there's actually quite a dramatic cliff collapse just around the coast a few years ago. So this is another like really high priority to investigate before it was further damaged. So we had just a day there in August last year. We spent quite a lot of that time clearing the cobbles off. And this was after the sort of initial clean. You can see there's a lot of clean sand there, but there's a line of midden just at the back of the area that we'd cleared there. It's really just a sort of lens in the coast edge. And there really was just the thinnest sliver of this midden left from where we cleaned back from, being heavily eroded, really truncated by the sea and by that sort of steep slope of the beach there. And we also had this darker patch of cobbles and a potential structure with a sort of upright orthostat much further down the beach, which we thought might be the remains of some sort of structure. Now that's the midden. It really was just a thin strip of it, but it was lovely. It was so productive. We got a lot of Middle Iron Age pottery out of it, and we got bits of a cow skull as well, and it's so productive in terms of seashell as well, full of charcoal. And it really popped out from that lovely clear sand, but it had unfortunately been compromised already by coastal erosion, because if you see that sort of darker patch of sand just at the pointy end of my ranging rod there, that's modern beach material that's been washed in underneath the midden. So what seems to have happened is that the sea has actually come in from the side. There might have been a large stone or something in there, and if you think of the slope of the beach, all I can think that happened is that the sea sort of, in a and a big storm pulled out a stone, sort of it from the side, and then just reworked and redeposited all this modern material, including a green plastic bottle, what looks to be underneath an Iron Age midden. So unfortunately, it's already been quite compromised by erosion there. And the same, unfortunately, was true of the promising sort of structural evidence further down the beach. Everything there was just very, very beachy material all the way down to the base of that orthostat. There were sort of patches of clay with flecks of charcoal in there, but it had all been reworked and redeposited material. So there's modern beach sediments and shell fragments and beach cobbles in there. So there was no intact in situ archaeological deposits left there, unfortunately. That orthostat did have like edge set packing stones around it, so we think it probably had been structural, but it was just the very last remnant of the structure clinging on, and probably had acted as a scour pit, allowing the sea and the waves to get in and sort of swirl around and just rework all of that archaeological material and redeposit it with modern beach stuff in there. But on a positive side, we did get a result there. We had this fantastic assemblage of prehistoric mid to late Iron Age pottery, as well as a couple of later pieces, including some Hanseatic stuff as well. So we know there's a lot going on there, and it's definitely worth keeping an eye on. It's just this one might have been an example of just being a little bit too late for exactly where we were looking, unfortunately. But just before I finish, I want to go to one mystery and one site that we really did manage to solve. So this is Gossabra up in Yale, which again was brought to our attention by Archaeology Shetland members. So we've got this lovely sweep of beach and the old Ha house, which was occupied really until quite recently, being the local shop as well, supplied by the Earl of Shetland boat. So in 2020, Archaeology Shetland members, I think in April or May, had reported that there looked to be a stone kist, a sort of stone box formed of flat slabs eroding out of the coast edge just in front of this structure, coming out of the sand dunes. So when I was up there, I took the opportunity to go along and investigate. By the time we got there in August, one of the sides of this box had already collapsed. So that really shows that even in the sort of gentle summer months, there could be a lot of damage done in the sort of very fragile sandy landscape. And when we looked, we sort of saw it hadn't just been a single box, but it had actually had, it seemed like a central vertical slab, which acted as a divider, as a sort of two smaller adjoining little cubbyhole style boxes. But the very thin stone slabs that it was built of very rapidly turned out to be, in fact, reused roof tiles with these lovely peg holes for holding them in position. So clearly not prehistoric and not funerary either. So not the sort of prehistoric kist that we'd been expecting. So these tiles, Ian Tate has told me, were quarried only from Bressa, a quarry that operated from around 1600 up to the mid-19th century. So we assume that they'd been the original roof of the old Ha and had just been put to secondary use in the construction of this box feature, probably in the sort of late 19th, early 20th century, we think maybe. From cleaning the section, we also saw that the box had been cut into the sand dune, so definitely cut in from above, but cut through different material on either side. And that darker sand on the right-hand side of it, and those sort of stones, we did wonder if it might have been the sort of very ephemeral, very damaged remains of a noost or something, possibly. But none of that really helped us decide what this weird little box structure might be. Clearly not funerary and very definitely not prehistoric. But it's a bit of a mystery, really. We've had a few suggestions. Someone thought sort of cold storage, like underground storage, without refrigeration, particularly with it being the shop. It's also been suggested it might have been something as simple as a post socket for a strainer in a fence, in a post and wire fence, which in that sand might have needed a bit of extra support. My personal favourite, of course, is that it was a smuggler's hiding place, just adjacent to the pier where sort of contraband and alcohol might have been hidden. So, any suggestions are welcome. I would love to have a lot of fun speculating, even if we can't definitively prove what it might have been. So although it you know, it doesn't have the issue of human remains here. It's not funerary, and it's much later than we expected. It's almost more exciting because it's, as far as we know, it's a completely unique feature without any parallels, and it's still a mystery. So it's that's really quite exciting in itself. And while we were there, we also took the opportunity to record another site in front of the old Ha. So it's a very common site, but really quite interesting in its own way. It's a former peat stack, which had then been exposed in section by the erosion. So you can see the very clear bands of the black processed peat and the very white layers of wind-blown sand interleaved with that. So it's a marker of past storm events when sand was blown in and deposited by the wind all over the peat. So although it's a sort of prosaic little site, it really is a little piece of classic Shetland history, I think, you know, peat cutting for fuel. And it sort of tells the story of climate change in a way as well. You know, it's prehistoric peat, which, you know, formed thousands of years ago. It was cut in fairly recent history to burned as fuel, which released carbon back into the atmosphere, so sort of contributing to the issues of climate change, only then to be sort of re-exposed by sort of climate-driven erosion, and the sort of interleaving of the peat and the white layers of sand sort of show as markers of past storm events and sort of act as a proxy record of past climate events. But while we were there, we did also get the opportunity to record a completely new site. This is something that wasn't on our records at all. And it's just along the coast, just at the sort of rocky shoulder of the bay. I had no idea it was there. It's always worth going for a walk on the beach and just seeing what you can see. And it appears to be a prehistoric structure and associated midden. You can see the stone walling of the structure there. It's just, apologies for the rather rubbish photos. The day I was there, it was too wet when I went back to record it, to put the drone up here, and the sun was just sort of right in the worst place for getting a photo, unfortunately. But there's stone structure in there. There's midden. There's burning. There's peat ash. There appears to be spreads of quartz, what looks like it might be worked quartz, and pottery in there as well. And that's just spread out over the distance of a few tens of meters at the corner of that bay, which again was completely unknown prior to the whole site being flagged up by that little box built of old roofing tiles. So it just goes to show that, you know, there always is something new out there on the coast. It's always worth keeping your eyes out for. There's always something unexpected and something surprising, and hopefully that's what the sort of little tour of eroding sites around Shetland has shown, that there is always something surprising, and sites aren't always what you expect either, but there's always something that we can learn from them, and it really is so important to keep your sort of eyes and ears on them. And it really does show how important it is to monitor them, but also to look out for new exposures, not only to sort of get those records of erosion, but just to sort of flag up when something new is being discovered. And that's why it's really good to know that the Archaeology Shetland are out there. You know, you're still keeping an eye on Shannerwick, you're still reporting these sites, and you're still recording that erosion for me to sort of go and analyse and quantify with my erosion assessment. So I just really want to finish by saying a big thank you to you for listening, and a really massive thank you to Archaeology Shetland and all the members and all the volunteers who've reported sites, who've come out, monitored the coast, and have helped us to investigate those sites. And please, you know, keep in touch and carry on telling us about all these exciting discoveries around the Shetland coast, because they never stop coming. So thank you very much. And of course, I'm delighted to take any questions anyone might have.
Well, real quick before we get to the questions, big thank you to Ellie for that presentation. That was wonderful. And it was just a great place to segue into talking, just to introduce 3 of the events that we're going to be doing this year. We are going to be cleaning and recording 3 sites on coastal edges: the Sands of Sound, sand out on the west side, which that structure appears to almost be gone, but we did find bronze, late Bronze Age, early Iron Age pottery eroding out of that one. Hopefully it survived the winter, because we were trying to get there in December. And then provided when Ellie's coming up, we're also going to do gelatinous over in Nesting, which is another site that's rapidly getting lost to the sea, but we have some exposed park material now, so it's critical that we take advantage of it while we can. So anyway, just to let you know that, and we'll move forward to any questions for Ellie.
Gosh, am I completely off the hook, or have I just bamboozled everyone with flinging information at you like foam or vomit?
Well, no such luck. I actually have a question. How easy is it for those of us that don't work, with like a lot of the formulas that you're using? Like, say I wanted to apply how much potential loss there's been at sand out on the west side when we go to do a clean and record on that. Is it quite a difficult process to try to sort of measure how much might have potentially been lost?
It really doesn't have to be. So the method I use is drone survey to give you the sort of overall landscape view. But it's entirely possible to do it in a much more sort of low tech way as well. Just because if I'm correct from remembering Sands of Sound, you have you do have like features nearby. You've got a fence line and a path nearby. Is that right?
Yeah, it Sands of Sound. It's a structure. That particular structure has been eroding for years, and I think we just finally want to solve that one, because that could be anywhere from a boat noose or World War II material all the way back, and it's just trying to figure that one out.
Yeah, I'm thinking. I mean, you don't need the sort of fancy GPS equipment or a drone survey to really quantify erosion. If you have sort of hard points in the landscape that you can measure off from, just a fence line or the corner of a path or a fence post or something, you can just take measurements along the ground, and sort of do it in that really sort of straightforward sort of way. Just old-fashioned tape measures. That's really straightforward. Just literally, I mean, you can either sort of hammer in just some old rebars or something, if you've got the landowner's permission, and then you have like a sort of permanent, or as permanent as it can be in an area that's eroding. Just measure off those sort of every so often, and that'll just help you quantify it. Essentially, just be like the manual version of the transects that I calculate in the GIS program. But anywhere there's a permanent survey marker, just run your tapes off it. Whether it's a fence line or anything. I was actually at the conference in Portugal. I was talking about when I got really ill. There was a woman there who's comparing 3 different methods of coastal erosion, sort of monitoring. One is a drone, one is a very expensive piece of GPS equipment that essentially, it's horrible, you put like an aerial on your head in a baseball cap, and it turns you into some sort of cartoon type character. God knows what it does to your brain, but she just walks along the coast and sort of maps the coast with this like GPS aerial on her head. And the third method is just manually measuring transect, just with a tape measure off a permanent survey baseline, and they're all as good as each other. They're all like the sort of manual method of running a tape measure off a sort of hard line on the coast edge is just as effective as flying a drone or walking around with this GPS aerial in a hat on your head. So it doesn't have to be high tech at all. So, and you should be able to get access from things like National Library of Scotland. You can get historic map images and historic aerial photos and things as well, and that can help you to quantify how much erosion you might have lost over that period of time. So yeah, it doesn't have to be high tech. You don't need drones, although it's always good if you can fly a drone as well, as long as you can get landowners' permission, because flying drones is fun.
So should I change it to help Archaeology Shetland buy a drone?
Absolutely, yeah. Just make it a small one. They're changing the laws, so don't buy a big one like mine, because you'll be very limited where you can use it. Buy a nice little compact small one.
You presented, Ellie, the change at Channelwick recently as due to storm activity and compared that to a long-term change. Is it likely that the long-term changes were actually also episodic and would correlate with storms? I've taken a little interest in storms recently and have an interesting compilation sitting on this table, which I was going to look at over the last couple of centuries.
Oh, interesting. I would love to know more about that actually, because I've just been using sort of storm records from the Met Office. Yeah, I suspect that yes, the long-term average that we're looking at is essentially evening out, probably sort of one or two, or maybe three or four specific events that have caused like a sort of step change and then it stabilized. There might just be sort of very, very slow sort of crumbling of the coast edge, but I think it is like step change, very little change, and then another step change. And I suspect if we had the data that would allow us to look at the shorter time periods further back, they would show a similar story to what we're seeing now. So I mean, I am very aware, when I'm sort of boldly projecting these rates into the future or into the past, they are long-term averages, and they sort of don't take account of those of the specific impact of particular events. But I think looking at the long term, you are going to sort of be able to even that out and get a big picture, because I mean, I would never say that the period from 2008 to 2016, take that average and project that in one direction or the other. But yeah, I think in most cases there will be a very slow rate of erosion, but the vast majority of it probably can be accounted for in one single chunk that's due to a specific storm or series of storms that happen over a short period of time, which I think is the case at Channelwick. There's just like something like 9 storms over a 3-week period that just the system didn't have time to recover from, and that's what did the damage.
The consequences of climate change is increased storminess, of course. So the projection in the future might be actually worse than even you suggest.
Yes,
it's
yes.
Unfortunate. It's
very difficult to account for future storminess because it is so uncertain. We just don't know how it's going to be. But I think also changing direction of storms is what's going to cause the damage as well, because like the West Coast is kind of acclimatized to it. It's almost reached an equilibrium with the prevailing conditions. So it's when they come from a different direction that really does the damage, which again was the case in Channelwick. You so rarely get a southeasterly like that. That when it does happen, the coast edge just isn't used to it, basically, just not set up to deal with those impacts.
Thank you.
Oh, thank you, Celia. Glad you could make it from Chichester. Oh.
Cirencester.
Cirencester, sorry. And I hope you didn't get bitten by the cat either.